Ocean acidification shipping. Our project is focused on ocean acidification in relation to shipping, which is why for our chemical reactions we focused on the combustion of methane and petroleum. For methane, the chemical reaction is CH4 plus 2O2 equals CO2 plus 2H2O. When methane burns in the air, it has a blue flame. In significant amounts of oxygen, methane burns to give off carbon dioxide and water. When it undergoes combustion, it produces a great amount of heat, which makes it a very useful fuel source.
For the combustion of petroleum, the chemical reaction is bunker fuel plus O2 equals CO2 plus H2O. This is important because the combustion of petroleum releases CO2, which can cause ocean acidification. When carbon dioxide is released into the atmosphere, it can cause damage environmentally and can have health impacts. For example, CO2 increases in temperature and increases humidity. This dries out agriculture. CO2 can also have health impacts like headaches, dizziness, pins and needles feeling, difficulty breathing, coma, asphyxia, and convulsions. The impacts of the release of these extremely harmful chemicals are very important to look at because it will affect so many people, ecosystems, and in turn harm us economically, health-wise, socially, and environmentally. To show the impact of ocean acidification with marine organisms, we conducted an experiment where we tested different pHs of distilled water to see how it affects marine life. To bring up the pH and bring down the pH, we added baking soda and vinegar. The first beaker had a pH of 8.2 because that was the pH prior to the Industrial Revolution. The second pH had a beaker of 8.1 because this is the average pH of our oceans today. The third beaker had a pH of 7.9. We use this pH because that is the predicted pH of the oceans in 2050. The fourth beaker was the control and had just plain distilled water. After we had all of our waters at the desired pH, we placed one shell into each beaker and let them sit in the beakers from Friday at 9:30 to Wednesday at 9:30. We took the mass of each shell prior to putting it in the water and after. The mass went up for each shell by about 0.2 or 0.3 grams. The biggest increase was the beaker with the pH of 7.1. The shell started with a mass of 0.63 grams, and when we weighed it on Wednesday, it had a mass of 0.66 grams. The pH in all the beakers went up as well, meaning by adding a shell, CaCO, the water became more basic.
Things like shipping and other greenhouse gas emitters release atmospheric CO2 and other pollutants. This pollution is released into our atmosphere, and 30% of this pollution ends up in our ocean. This pollution changes the pH of our ocean water and changes temperature. This makes the ocean hostile for ocean organisms, for example, shells and coral, and fish and other ocean animals. These models show the release of greenhouse gases and how they end up in the atmosphere and then end up in the ocean. In this model, you can see the molecules and how and when CO2 goes up, the other elements go down.
Now we know this all seems like a lot of scary data on how our world is negatively changing because of greenhouse gas emissions and ocean acidification. But by making changes to how we operate in the shipping industry, we can significantly cut down the release of harmful chemicals. To make an easy change and reduce the amount of emissions, we propose that regulations should be put in place to lower the speeds of ships. This in turn will help the amount and rate these ships are burning fuel. By reducing speed, it can help the climate and can help the economy because of oil shortages that have been occurring all over the globe. A quote from the article titled Shipping Pollution by Oceana stated that the IMO calculated that a speed reduction of just 10% across the global fleet by 2010 would result in a 23.3% reduction in emissions. To show this, we calculated the amount of CO2 that would be saved by reducing speed by 10%. Here's our calculation, and Nick will explain it.
There's 15,106 cargo ships that get 4.5 miles per hour to gallon, with the average speed being 23 miles per hour. So if a cargo ship goes 5 miles per hour, it'll give off 100 pounds of CO2. And if we reduce that by 10%, going 2.3 miles per hour, at least 10 pounds of CO2. Since there's 15,106 cargo ships, that means there is 1,510,600 pounds of CO2. But if we reduce that by 10%, it becomes 151,000 60 pounds of CO2. So if we convert that, if we subtract this from that, we would get 1,359,540 pounds of CO2. Converting this to grams and then to moles would be 349,231,306 moles that are saved.
This change will not prevent these horrific environmental, economic, and social changes from occurring, but it will help slow down the progression of these changes, which can buy us some time to come up with more permanent solutions.